Good afternoon, dear colleagues. For your attention presents the research of Taras Shevchenko National University of Kiev on the subject of input data requirements for person identification information technology. Improvement of face recognition and biometric technologies have led to increasing of accuracy, availability, and consequently to widespread usage of automated face recognition. It means that face recognition can be used on an even larger scale and in more complex environments, for example, by special operation forces on drones for intelligence gathering, rescue missions, perimeter protection, and indoor search operations. However, the ways in which face recognition and identification technologies are used for military purposes are subject of public criticism because any errors of the software or those who use it can have irreversible consequences. Therefore, the study of recognition and identification algorithms is relevant in order to increase their efficiency and reduce the probability of false identification. In our previous work, the person identification information technology based on local texture descriptors was proposed, in which the algorithm is underlined that consists of the following methods: color features for detecting and localizing the face recognition in images, Weber wavelet transform for image processing, histograms of oriented gradients and local binary patterns in one-dimensional space for extracting image feature vectors. Mathematical models of these methods are depicted on the screen. According to the results of our previous studies, the effectiveness of the algorithm used for person recognition and identification on face images can significantly vary on different datasets. Such problem can become a significant obstacle to the correct identification of a person and cause errors in the identification process if the parameters of the images stored in the database and the images that are given to the input of the algorithm vary essentially. The purpose of this research is to determine the requirements for the information of test and etalon image samples, the use of which would allow to obtain the highest accuracy rate results of the person identification after applying proposed combination of methods. To conduct the experiment, 7 databases were selected that contain images captured in constrained as well as unconstrained conditions close to the natural environment in which human faces can be observed. Since face images databases usually have variability in image properties such as format, resolution, and the size of the image region containing the person's face, it was decided to conduct experiments using different parameters of these properties to form requirements in regard to the technical characteristics of face images to which the developed algorithm will be applied. Thus, the experiments were conducted in 3 stages. The first set of experiments was performed on face images that were converted from the original format to the image formats PNP and PNG, which are compressed image formats, and JPG, which is an uncompressed image format. The second set of experiments was conducted with the resolution conversion of the original images. The image resolution was converted to a fixed height value only, and the width was automatically determined in such a way as to keep the aspect ratio constant. In the third stage of the study, experiments were carried out on face images transformed in such way that the images contained only the face features of the person without any other detail. Since the results of the study are quite extensive, only some of the tables are shown on the slide as an example. On the screen, there is presented the comparative diagram of the results of experiments conducted on original images and with format conversion. Analyzing the results that obtained on the database of faces and Ferret database, it can be concluded that the format of the images that are given to the input of the algorithm in some cases affects the efficiency of the algorithm. On all other databases, the results are constant, regardless of changing the image format. It is worth noting that all these databases contain images in JPG format, so this format is the most suitable for images to which the studied algorithm will be applied in the future. On the screen, there is presented the comparative diagram of the results of experiments conducted to investigate the resolution of input images at which the algorithm is most effective. The highest identification accuracy rate among all sets of experiments, that is 95%, was obtained on images from the SCFace database, the resolution of which was converted to 108 on 144 pixels. On the screen, there is presented the comparative diagram of the results of experiments on images that contains only the face region without any other details. Analyzing the obtained results, it can be concluded that the identification accuracy rate is significantly reduced when this type of transformation is applied to images. This may indicate that the face detection and region resizing methods available in the studied algorithm successfully process the input images, regardless of whether the input data contains any details other than the human facial features. It is important to note that the images contained in all image databases on which it was possible to achieve higher accuracy results after applying the studied algorithm were captured in constrained or semi-constrained conditions. The database of faces contains images on a uniform background with frontal positions of faces. Red contains frontal images aligned and captured under the same physical settings. SC face contains images captured under the same lighting conditions using cameras that had an unchanged position relative to the subject. One of the mechanisms for increasing the accuracy of recognition and identification is a clear formulation of requirements for images. Considering all the studies carried out in this work, it is possible to clearly formulate the described in detail presented on the screen input images requirements regarding format, resolution, subject's head position, lighting conditions, distance between the subject and the camera, time interval between the captures of the images, and so on. The results of conducted experiments allow to make the following conclusions. The lower limit of the accuracy of identification on images from all datasets was obtained during experiment with transformation of images in such a way that they did not contain other details except for the face region. It means that the face detection and localized region resizing methods contained in the algorithm are sufficient for further processing and successful classification of the image feature vector. Also, the impact of the format and resolution of the images given to the algorithm input on the subsequent efficiency of the identification process was found, which indicated the need to set requirements for such image parameters. The highest accuracy of identification by the algorithm was obtained after its appliance to the databases that contain face images captured under constrained conditions and uniformed within the database. So as a result of the research, it was determined that the proposed information technology allows to obtain the identification accuracy rate of up to 95% during its appliance to images that were captured under constrained conditions and uniformed within the same database. As a result of the analysis of experimental results, the requirements for the images to which the application of the algorithm is the most effective were determined. That is all. Thank you for your attention.